Okay, in this section from the red slice, we will be looking at normal distribution raw scores. And this one then puts lots of pieces together from previous lessons. And it's a word problem, so let us read it carefully. Calcium levels in people are normally distributed with a mean of 9.4 milligrams per deciliter and a standard deviation of 0.3 milligrams per deciliter. Now, individuals with calcium levels in the bottom 5% of the population are considered to have low calcium levels. Find the calcium level that is the borderline between low calcium levels and those that are not considered low. Carry your intermediate computations to at least 4 decimal places and then round to 1 decimal place. Okay, this is a fairly complicated problem, and what we're going to need to do here is to review a little bit about x-scores and z-scores, converting back and forth between them, and then going ahead to solve this problem. So let's move over here and take a look at our notes. Okay, using one of our worksheets here, made a few notes. First of all, remember here that your standard normal values are called z-scores, and they started in the center with a mean of 0, standard deviation of 1. Now in this case, we know that these values that we're working with are normally distributed, but they have a mean of 9.4, which means that the 9.4 is in the center, and the standard deviation is 0.3, which means that we will mark off by 0.3s. So going from the mean to the right, we will add 0.3, and from the left, we will subtract that. And I've done that for you. Now keep in mind that what our answer is going to be is one of these x-scores. It's going to be one of these numbers along this number line someplace. But here's our problem. We don't know what that is. Now what we do know is that wherever that particular number is going to mark off or divide the normal curve into two parts. It's going to be in such a place that we will divide the bottom 5% from the rest of the graph. Now once again, we think about the normal curve and we remember that this total area here is 1 or 100%. We notice that low numbers are over here, high numbers are over here. So the bottom 5% would be a little bit of this area, but on this left side, over here someplace. And I'm not sure just where that is. So what I'm going to do is just sort of make a guess. I'm going to draw it in here someplace. This could be wrong, okay, but I'm going to draw it in here. And once again, this bottom 5% is going to be this area in here. This is the bottom 5%, or we can say that this area that is under the curve here to the left of our unknown x-score is negative 0.5. Well, as you might guess, in order to be able to come up with the value that we need, we're going to also have to be using the standard normal, or the z-values. So we're going to need that, and we're also going to have to be doing some conversions. And so, in this case, we're going to take the same formula that we used in a previous one and do some algebra with it. And I will spare you that, and I will just give you the magic formula that x is equal to z sigma plus mu. So that is the magic formula that's going to allow us to convert basically z-scores into x-scores. Now notice here that we know some things because we have sigma, and our sigma is 0.3, so we can put that in here. We know mu is 9.4. We can put that in here. What we lack is a z-score. Now, if you remember, on the ALEKS calculator, we have a Z button that's all about finding that. So you might need to review about those standard normal values. But let's go back to ALEKS and let's find our Z button. Here it is right here. Now remember how this button works. This button likes the area to the right, because if we enter here the area under the curve to the right of the z-score, it will tell us what that z-score is, and that's what we need. But if you take a look here at our notes, you will see that this 0.05 is the area under the curve to the left of that unknown z-score. And we can see that that unknown z-score will be up here in these numbers someplace, but I'm not just sure what that is. So what I'm going to need to do then is to realize, first of all, that this area over here is 0.05, so this area over here is 1 minus 0.05, or 0.95. And what I will need to do for this particular z-score here then is to simply take the z of 0.95. I've got a button that will just do that, and that's going to give me my x value. So I'm going to take the z of 0.95, multiply by 0.3, and add 9.4, and I can do that all in one step on my ALEKS calculator. Let's go do that right now. So what I'm going to do here is to take the z of 0.95. I'm going to multiply that times sigma, which is 0.3, and I'm going to add 9.4. ALEKS tells me that my answer is about 8.90. They want this to one decimal place, so 8.9 should be the answer in ALEKS that we want. And we are good. Now, there are some variations to this problem. Let me tell you about those. Sometimes they don't ask for the x as an unknown. They may give you that, and then they may leave the unknown to be either the mu or the sigma. In any event, you would set it up the same basic way. Plug in the parts that you know, and then use algebra to solve for the parts that you don't know. So be cautious, read carefully, and practice this well.